Hi, everybody. We are now on chapter 5.3, Logarithms. This is continuing from the first two sections on just exponentials, and we're going to be introducing a brand new concept today in this video and the videos to come on 5.3. So in this video, we're going to be talking about a concept called a logarithm. And we're going to kind of introduce what this concept is before we go any farther into learning more about it. So to kind of introduce it, logarithms are just a different way of looking at exponentials. Exponentials are something you were introduced to in middle school and then practiced more in Math 1. And now we are looking at expanding that knowledge here in Math 3. So the idea of an exponential, we could write out an exponential as simple as 2 to the power of 5 is equal to 32. We know that's true. We can put it in our calculator and confirm that. We also know the parts of this particular equation. We know that the 5 right here is representing the exponent. We also could give it different names like an index or a power. We'll write power here. The 2 on the bottom, well, it's on the bottom, so we know that's called a base. And the 32 is the answer, or it's the result. And we're going to go with result as a word here to represent what we get at the end of an equation. So I want to try to put this into terms we've talked about recently, and that would be exponential growth. So as my example, I'm going to pick something called a water lily or a lily pad that you might see in a lake or a body of water like that. So these are a plant that can double in size almost every single day when it's in its peak growing season. So we would basically say in terms of this that it's doubling. So that's the 2. So we could say base / growth rate. We could say that the 5 is that's how many days that have elapsed. So we could say / time. And if we are doubling the size of this particular plant over 5 days, well, that means it's 32 times bigger than when it started with. So that's a kind of real world example to base ourselves in for right now. So let's think about expanding that a little bit more. We also know that 2 to the power of 0 is going to be equal to 1. Let's think of it in terms of the water lily. We could say that, well, we know that it's doubling. The 0 means that 0 days have elapsed. So if 0 days have elapsed, it hasn't grown at all. It's still 100% of what it started with. It has multiplied itself by 1. It hasn't grown at all whatsoever. So we know that this makes sense. Our growth rate is 2. It's doubling. 0 time has elapsed, 0 days. And we know that, well, if 0 days have elapsed, it hasn't grown at all. It's 1 times bigger, which is no change at all. So we can also think about it in terms of 2 to the power of -1. Another exponent rule we've talked about pretty recently. That would be the same thing as 1 over 2. So let's ground this in the real world as well. We know that the time, well, it's -1 days. So if I know that -1 days have happened, well, I got to look in the past by 1 day. So if it's doubling every day, if we go backwards, it would be half the size of what it started with. So if 0 days have happened, it's the same exact size, 100% of its original. If we go back a day before that, it would be half the size of that same original. Okay, now that we have all of these exponential equations written out and we can follow what's happened here, pretty familiar, we're going to change these into logarithms and talk about what each part of that logarithm means. So we'll draw an arrow here. So if I were to write out this, I would write it as log. You write log instead of logarithm because it's shorter. And we would have the base of 2, just like base over here. We have an input, which is 32. And we have the only thing left is our exponent. So I would read this as the log base 2 of 32 is equal to 5. And I'm going to write that out right underneath. Log base 2 of 32 equals 5. Always a good idea to know how to read something in math so that you can speak to your classmates, speak to your teacher in an effective way, and have people know what you're talking about. Now, if we think about it in terms of our water lily, well, this is just a different way of thinking about the same thing. Well, we know our growth rate is 2, and we know that the flower, the lily pad, would be 32 times bigger. So how long would it take for that to happen? Well, it would take 5 days. Growth rate is 2. How long is it taking to get to 32 times bigger? And the answer is 5. Now let's apply this to the other 2 examples. If we write out our second exponential equation, well, this would be written as a log base 2 of 1 equals 0. Thinking about the water lily, well, if our growth rate is doubling, or 2, how long would it take for the flower to be exactly the same size? Well, if a flower is growing and it's exactly the same size, well, that probably means 0 days have elapsed so far. And finally, our third one here, we could write as log base 2 of 1/2 equals -1. Now, if I think about this last one in terms of the water lily, I would be able to think, well, if my growth rate is 2 and I'm half the size of what I'm supposed to be right now, well, that means that I'm talking about 1 day ago, 1 day in the past. Now let's look at a little bit different of a scenario here. So if we don't have a plant that's doubling anymore, let's say that we have a plant that is tripling. So log base 3. Our growth rate is 3, and our plant is tripling in size every day. And we want to know how long it would take to end up being 81 times bigger than when it started. Well, if we're not sure, we could start figuring out this by hand. We could do 3 times 3 is 9. Well, that's 2 threes so far. 3 times 3 times 3 is 27. That's 3 threes so far, or 3 days. And we could put in 3 times 3 times 3, or 3 to the 4th, gets us to 81. Now, that means that we needed to triple over 4 days for our plant to be 81 times bigger. And that means our answer for this logarithm would be a 4. In our next video, we're going to talk a little bit more about this conversion between them, but we can kind of draw an arrow here between these two where we are basically writing as, well, 3 is our growth rate to the 4th power is going to be equal to 81. We need 4 days at a growth rate of 3, or tripling in size, to now be 81 times bigger than what we started. In our next video, we will be talking more about logarithms and talk about how to go between exponentials and logarithms and evaluating logarithms and elaborating a lot more on this topic. And I will see you all next time.